Welcome to another fantastic lesson. This lesson is on factoring. Today's objectives is to factor GCFs, which is otherwise known as greatest common factors, and to factor what's called quadratic trinomials. Quadratic meaning the highest power of 2, so something like x squared. And the word trinomials meaning three terms in the polynomial. So for example, x squared minus 2x minus 3, something like this. Let's take a look at our first objective, which is on factoring GCFs, or greatest common factors. Remember the process with radicals that we talked about before. For instance, if we had the square root of, let's say, 28x squared y, and I told you to simplify that radical. The first step would be to make a factor tree of 28, get that down to the prime factorization, also expanding the two variables. When we do that, it becomes 2 times 2 times 7 times x times y. The next part was to look at the index, which here, of course, square root, it's 2, which means for every pair of factors, we can pull out one of them. The same process can be done with factoring out what's called GCFs. In fact, the first step is to expand the polynomial as much as you can. Let's take a look at our first example of what's called factoring out a GCF, or greatest common factor. Here you notice we have two terms, 3x squared and minus 6x. Your goal is to get the coefficients into their prime factorization, also expanding the variables as much as possible. For example, the term 3x squared can be expanded as 3 times x minus the term of 6x can be broken up into prime factorization of 2 times 3 times the variable of x. The next step is to look at shared factors between each term. Here you notice we have a 3x and a 3x in the second term. That's what we can what's called factor out of the polynomial. When we factor it out, we put it in front of a set of parentheses like this. What goes inside the parentheses is your leftovers. If you notice, we have an x and a negative 2 that's left over. That goes inside the parentheses for a final answer of 3x parentheses times x minus 2. This is fully factored. What's nice about these types of problems is you can always check your work. If we were to do the reverse, such as the distributive property, distributing 3x to both of the terms, checking our work, we would get the polynomial of 3x squared minus 6. So this is fully factored. Let's take a look at another example of factoring out a GCF, greatest common factor. The only difference here is we have an extra variable. We still have two terms, 4x squared y cubed and 8x cubed y squared. If we were to take a look at the first term of 4x squared y cubed, the prime factorization of 4 is 2 times 2. Expanding the variables of x squared becomes x times x. Y cubed, therefore expanded, would be y times y times y, three factors of y. Plus, if we were to expand the coefficient of 8, the prime factorization here is 2 times 2 times 2. Expanding the variables of x cubed y squared becomes x times x times x times y times y. Here, if you notice, we have a few shared factors. In fact, we have two sets of 2 in the first term, two factors of 2 in the second term. We also have two factors of x and two factors of y. So what we can factor out of the polynomial here, factoring out both factors of 2 becomes a factor of 4. Factoring out two factors of x becomes x squared, and two factors of y becomes y squared. What we're left inside the parentheses are the leftovers. In the first term, you notice we have an extra factor of y. In the second term, we have an extra factor of a 2 and also an x. So inside the parentheses becomes y plus 2x. Our GCF here is considered to be the 4x squared y squared. So this is our final answer. The next objective today is what's called factoring quadratic trinomials. This is an example of a quadratic trinomial. X squared minus 4x plus 4. The quadratic part is the degree of 2, and the trinomial meaning 3 terms. Remember last unit when we talked about foiling two binomials. For example, we have x minus 2 times x plus 3. When we did the FOIL method, it stood for first, outside, inside, last. So multiplying x and x becomes x squared. The outside-inside part of 3x times a negative 2x gives us a total of positive 1x. And the very last part, negative 2 times 3, becomes negative 6. Essentially, when you're factoring quadratic trinomials, you're doing the reverse process of foiling. You're taking something written in a quadratic trinomial and writing it in the expanded form of two binomials. So essentially what factoring is breaking it up into two parts, two sets of parentheses. It's the reverse of FOIL. Let's take a look at this example. Let's factor x squared minus 5x minus 24. There's actually two ways to factor these trinomials. The first way I'm going to talk about is what's called the trial and error method. The second way is what's called the box method, and you can choose whatever method you want. With trial and error method, the first step is to break up your two sets of parentheses. We know our factored form is going to be two sets of parentheses. The next step is to look at the leading term of x squared. The only way we can really expand x squared is x and x. So that becomes our first term in both sets of parentheses. The next step is to look at the constant term of 24 and write out the factors of 24. Factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. These are all the factors of 24. The next step is to look at the sign that's at the end of the trinomial. Here it's a minus sign. That tells us to look at factors that have a difference of the middle term, which here is 5. Which factors of our 24 have a difference of 5? If you notice, 1 and 24 has a difference of 23. 2 and 12, difference of 10. 3 and 8, the factors have a difference of 5. Those are the numbers that we put inside the parentheses. So we put a 3 here and the 8. Now the only part that's left is to really put the signs. Where does my plus, where does my minus sign go? If you notice the middle term, there's a negative in front. Whatever the middle term is, if it's negative, the bigger factor is going to be negative. So it's going to be a minus 8 and it's going to be a plus 3. Again, what's really nice about these is you can always check your work. So if we wanted to, we could do the FOIL method, first outside, inside, last, to see if we get our original polynomial of x squared minus 5x minus 24. Let's try one more example of factoring a quadratic trinomial using the trial and error. So the first step, again, if you remember, is to set up your two sets of parentheses. The second step is to take a look at the first term, x squared. Again, the only way we can break up x squared is x and x, so those become our first terms in both sets of parentheses. The next step is to look at factors of the constant term. Here it's 12. Factors of 12 are 1 and 12, 2 and 6, and 3 and 4. If you notice, the sign in the back of the trinomial is a positive, which means what we're supposed to look for is factors of 12 that add up to the middle term of 8. Which factors of 12 add up to 8? If you notice, factors of 2 and 6 both add up to 8. Those are the numbers that we put inside parentheses, 2 and 6. What's nice about this is you can use a sign chart. If both of the signs in a trinomial are positive, you see a plus in the first part and a plus in the second part. Both of your signs in the parentheses are also going to be pluses, addition signs. So here we have our fully factored form of x squared plus 8x plus 12. And again, you could always check your work using the FOIL method. Let's take a look at a second method in factoring quadratic trinomials. It's called the box method. And the way it works is to first set up a box. The box is set up with 4 different quadrants with an empty circle inside, like this. The next step is to fill in the parts of the box. In the first part, the upper left-hand corner, your leading term goes there, x squared. In the middle circle is our middle term of 6x. In the very lower right-hand corner of the box is our constant term of negative 16. So as with the trial and error method, the next step is to really look at factors of the constant term. Factors, in this case, of negative 16. Well, negative 1 and positive 16, positive 1 and negative 16, positive 2 and negative 8, negative 2 and positive 8, negative 4 and positive 4, all the factors of negative 16. In this case, we want to look for two factors that always add up to the middle part of positive 6x. Which two factors that I listed add up to positive 6x? If you notice the first part, that adds up to a positive 15. Second factors add up to negative 15. The third factors, 2 and negative 8, add up to negative 6. And in fact, the fourth set of factors of negative 2 and 8 add up to positive 6. That's our two factors. We put those inside the box with the variable of x that we're using. So positive 8x and negative 2x. And it doesn't matter what corner you put those in. The next step is to look at the columns and the rows and factor out what's called the GCF like we did before. If you take a look at the first column, we have an x squared and a negative 2x. The GCF there is x, greatest common factor. Take a look at the second column, 8x and negative 16. The greatest common factor there is 8, so that's what we factor on top of the box here. Next, let's look at the rows. In the first row, if you notice, we have an x squared and an 8x. The greatest common factor between those two terms is x. That's what we factor out on the left side of the box. In the very last row, negative 2x and negative 16, the greatest common factor there is in fact negative 2. If you take a look at the outside of the box, we come up with our factors of x plus 8, which are the factors on top of the box, and x minus 2, which are the factors on the left-hand side of the box. This, in fact, is our factored form of the original quadratic trinomial of x squared plus 6x minus 16. Again, another method. Let's take a look at one last example, again using the box method. So the first step is, again, set up our box. 4 quadrants with the circle in the middle. What goes inside the upper left-hand corner of the box is our leading term of x squared. What goes in the middle of the box, the circle, is our middle term of negative 2x. And what goes in the lower right-hand corner of the box is our constant term of negative 15. The next step, if you remember, is to look at factors of negative 15. Factors of negative 15 are 1 and negative 15, negative 1 and positive 15, negative 3 and positive 5, and 3 and negative 5. The next step is to look at all the factors of negative 15 and to see which one adds up to our middle term of negative 2x. If you notice, the factors of 3 and negative 5 add up to negative 2x. That's what goes in the other boxes. And again, it doesn't matter where you put these, but remember to put the variable with them. The next step is to look at column 1 and to find the GCF of column 1. If you look at the factors of x squared and 3x, the greatest common factor of both of those is an x. Taking a look at the second column, the greatest common factor between 5x and negative 15 is negative 5. Next, we look at the rows. Row 1, we see there's an x squared and a negative 5x. The greatest common factor between those two terms is an x. In the last row of 3x and negative 15, the greatest common factor between those two is a positive 3. Again, your factors are located on the outside of the box of x minus 5 and x plus 3. So our factors, the factored form of x squared minus 2x minus 15 becomes x minus 5 times x plus 3 in parentheses. And that is fully factored. This concludes our lesson on factoring. Hopefully by the end of this lesson you've learned to factor greatest common factors and factoring quadratic trinomials using either trial and error or box method. Here I leave a few for you to try on your own. Come ready tomorrow to practice. Enjoy the night.